All of the compounds that we've worked on naming up until this point have been ionic compounds. They've contained a metal that's lost electrons to form a positive charge and a nonmetal that's gained electrons to form a negative charge. Covalent compounds are different. Covalent compounds have two or more nonmetals, and instead of somebody gaining electrons and somebody losing electrons, they are going to share electrons. Now, when we have two nonmetals, naming's going to be different because we can't just look at charges to figure out how they partner up. So we still name our first element first, and we're still going to use the full element name. We're going to name the second element second, and we're going to change the ending to IDE. Everything up to here is exactly the same as an ionic compound. Now here's where it gets different. We'll have to use prefixes. These prefixes are going to tell me how many of each type of atom I have. Now the prefix mono is never used on the first element. So here's the way my prefixes work. Mono, 1. Di, 2. Tri, 3. Tetra, 4. Penta, 5. Hexa, 6. Hepta, 7. Octa, 8. Nona, 9. And deca, 10. Make sure that you memorize these prefixes because you will need them for covalent compounds. Okay? So we said that mono is never used on the first element. The first element only gets a prefix if it's more than one. In this case, I have 2 nitrogens. 2 is di, so di-nitrogen. I always use a prefix for the second one. I only have 1 oxygen, so it's mono, and then I name the element oxygen, change the ending to IDE. Nitrogen, I only have 1 of them. Remember, I don't use the prefix mono on the first one, so it's just plain nitrogen. I always use a prefix on the second one, so since there's only 1, it's monoxide or monoxide. Okay? Nitrogen dioxide. Di-nitrogen trioxide. 2 nitrogens, 3 oxygens. Di-nitrogen tetraoxide. Okay, 2 nitrogens, 4 oxygens. So here's the way it works. Got some examples. P is phosphorus. I name the element exactly the way it appears. I only have 1 of them. Remember, I don't use the prefix mono on the first one. I've got 5 chlorines, so 5 is penta. Chlorine, I change the ending to IDE, so it's phosphorus pentachloride. In this case, I still only have 1 phosphorus. I don't put the prefix mono because I never use mono on the first atom, so it's just phosphorus. I've got 3 chlorines, so the prefix tri tells me 3. I change the ending on chlorine to IDE, so it's phosphorus trichloride. Take a second to solve example C. The nice thing about molecular compounds is I don't have to balance charges. They tell me exactly how many of each I have. Sulfur is S. There's no prefix, so there's only 1 of them. Hexa is 6. Fluoride is F, so it's SF6. Sulfur is still S. There's no prefix, so there's only 1. Tri is 3. Oxide was originally oxygen, so I've got SO3. Take a second and solve example C. Molecular compounds are much easier to name and write the formula for ionic compounds. Where it gets tricky is that people forget to check the periodic table to figure out what type it is. So it's really important that you're looking to see what you have. Do you have a metal? If there is not a metal, then we use prefixes. Okay? If there is a metal, then we come over here. I have an ionic compound. If the metal forms more than one charge, remember all of those ions in the middle, my transition metals. Okay? If it forms more than one charge, then it's going to be a little bit more difficult. If not, I just name the element and then give the ending IDE. If it has more than one charge, I need to use Roman numerals to identify the charge of the cation, the positive charge. Okay? So it's really important that you're paying close attention because naming's not very hard, but there are a lot of little exceptions and ways to screw it up. Where it gets more complicated is our final type of compounds that we're going to deal with naming, and those are acids. An acid is going to have one or more than one hydrogen ion. Now this has to be a positive hydrogen ion, so the H will always be in front. It'll be HCl, H2SO4, H3PO4, HC2H3O2, but it's always going to have an H in the beginning. Okay? Now, two different types. One type has a polyatomic ion. If the polyatomic ion ends in ATE, sulfate, phosphate, nitrate, I get rid of 8 and change it to ic. Okay? So here's my example. H, it's an acid because the H is in front. C2H3O2 is my polyatomic ion. My polyatomic ion is acetate, ATE. I get rid of the ATE. I change it to IC. So instead of acetate, I call it acetic acid. Okay? If it has a polyatomic ion, and the polyatomic ion ends in ITE, sulfite, phosphite, nitrite, I'm getting rid of the ite and changing it to OUS. Okay? So here I've got H, NO3. The H tells me it's an acid because it's in the front. Sorry, NO2 is my polyatomic ion. NO2 is the polyatomic ion nitrite. I take the ITE and change that to OUS. So instead of nitrite, it is now nitrous acid. Okay? Now, if it does not have a polyatomic ion, HCl, HF, HI, HBr, just an H with a single ion. Okay? I'm going to start with the prefix hydro. I'm going to then name the element that it's partnered with, and I'm going to change the ending to ic. So here I've got the H in the front. I know it's an acid. Chlorine is just a single element, so I start with the prefix hydro. I name the element chlorine, and I change the ending to IC, hydrochloric acid. Notice the only time I have hydro is when I do not have a polyatomic ion. Okay? So let's talk about our acids. Quick rundown. Remember, does it have oxygen or a polyatomic ion? All of my polyatomic ions that we'll worry about with acids have oxygen. Okay? If the answer is no, no polyatomic ion, hydro, change the ending to ic. Okay? If the answer is yes, no hydro, name the polyatomic ion. Change ite to OUS, change 8 to IC. Okay? So here we've got some examples. HClO3. ClO3 is a polyatomic ion. It has oxygen, so I do not give it the prefix hydro. All I do is I check the ending of the anion. ClO3, if I look, is chlor 8. If it ends in 8, I change the ending to ic. So instead of chlorate, I would call this chloric acid. Okay? HF. F does not contain oxygen. It's not a polyatomic ion, so I would go this way. I start with hydro. I name my anion, so the element, fluorine, but I change the ending to IC. So hydrofluoric acid. Okay? Take a second and solve C. Writing the formula is going to work exactly the way it did when we had ionic compounds, because the H is acting as an ion. Now I know it's always going to start with the H because it's an acid, and my H always has a +1 charge. Phosphoric acid, IC, since there's no hydro, was originally phosphate. So I'm going to find phosphate on my polyatomic ions. Phosphate is PO4 3 negative. When the charges don't match, I switch them. The 3 comes over by the H. The 1 goes over by the phosphate. So it's H3PO4. Sulfurous, again, still always starts with hydrogen, so I've got an H+. That's a 1. Sorry. Sulfurous, OUS, was originally ITE. So I look on my periodic table. Sulfite, ITE, is SO3 2 negative. +1 minus 2, switch charges. 2 comes over here, 1 comes over here. It becomes H2SO3. But notice both of my acids have to start with H. Take a second and write the formula for your last acid. Hydro, iodic acid. Make sure you balance charges.